Download this code from codegive.com, link in the description below. OK, let's dive into the concept of and the unnecessary in programming. This phrase, while not a formal programming term, effectively describes the problem of writing code that is overly complex, verbose, or includes elements that don't contribute to the core functionality or readability. It's about identifying and eliminating code clutter. We'll explore this through different lenses, including 1. Unnecessary variables and assignments. 2. Overcomplicated logic, and simplification. 3. Unnecessary loops and iterations. 4. Redundant code, duplication. 5. Unnecessary abstraction, over-engineering. 6. Unnecessary comments, and the right ones. 7. Unnecessary verbosity, and the power of conciseness. 8. Tools and techniques for identifying unnecessary code. 9. The importance of refactoring. 10. Code examples in Python, with comparisons. 1. Unnecessary variables and assignments. Sometimes, we introduce variables that don't really serve a purpose. They might store intermediate values that could be directly used or computed inline. Overusing variables can make code harder to follow, especially if the variable's scope is large. Example, Python. Explanation asterisk. In calculate_area_verbose, the area variable is assigned the result of length *width only to be immediately returned. The calculate_area_concise version directly returns the result, making the code shorter and easier to read. More complex example asterisk. Here, the list comprehension in process_data_concise eliminates the need for the result list and the processed_item variable, resulting in a more compact and expressive solution. 2. Overcomplicated logic, and simplification. Logical expressions can sometimes become convoluted and difficult to understand. Simplifying these expressions improves readability and reduces the chance of errors. De Morgan's laws and other logical equivalences can be helpful here. Example, Python. Explanation asterisk. is_valid_age_concise directly uses a chain comparison, which is equivalent but more readable than the negated or expression in is_valid_age_verbose. The check_range_concise function clearly demonstrates a more straightforward and Pythonic way to achieve the same result with less code and greater readability. Similarly, the check_range_verbose function uses unnecessary if and else clauses. If the first if condition is met, the function returns, making the subsequent if and else redundant. 3. Unnecessary loops and iterations. Sometimes, we loop through data when a more efficient method exists, or we perform iterations that are not strictly necessary. Python offers built-in functions and data structures that can often replace explicit loops. Example, Python. Explanation asterisk. Find_first_positive_verbose uses a standard for loop. Find_first_positive_concise uses next, with a generator expression. The generator expression creates a sequence of positive numbers, and next, retrieves the first element. If no positive number is found, the default value none is returned. This version avoids iterating through the entire list unnecessarily. The next function stops the iteration as soon as the first match is found. 4. Redundant code, duplication. Code duplication is a major red flag. It violates the don't repeat yourself principle. Duplicated code increases maintenance effort, as you have to make changes in multiple places. The solution is often to refactor the duplicated code into a function or class. Example, Python. Explanation asterisk. Initially, the calculate_rectangle_area and calculate_square_area functions perform essentially the same calculation. The calculate_area function combines these functionalities, using a default argument to handle the square case. This eliminates the duplication and makes the code more maintainable. 5. Unnecessary abstraction, over-engineering. Abstraction is good, but too much of it can lead to over-engineering. Introducing complex patterns or classes when a simple function would suffice can make the code harder to understand and maintain. Yagna, you ain't gonna need it, is a relevant principle here. Example, Python. Explanation asterisk. In this case, using a class, string reverser, to reverse a string is overkill. A simple function, reverse_string, accomplishes the same task with less code and complexity. The class adds unnecessary layers of abstraction when they are not required by the current functionality or anticipated future needs. 6. Unnecessary comments, and the right ones. Comments should explain why the code is doing something, not what it's doing. If the code is clear enough, comments can actually add clutter. Comments should explain non-obvious logic, edge cases, or the intent behind a particular implementation. Example, Python. Explanation asterisk. The first comment is redundant because the code return x plus y is self-explanatory. The second example uses a docstring to explain the function's purpose, parameters, return value, and assumptions, which is much more helpful. Good comments explain the why rather than simply restating the what. 7. Unnecessary verbosity, and the power of conciseness. Python, in particular, is designed to be a concise language. Taking advantage of its features like list comprehensions, generator expressions, and built-in functions can significantly reduce verbosity. Example, Python. Explanation asterisk. The list comprehension in squares_concise is much more compact and readable than the verbose for loop in squares_verbose. 8. Tools and techniques for identifying unnecessary code. Code reviews. Having another developer review your code is one of the best ways to identify unnecessary complexity. A fresh pair of eyes can often spot redundancies or overly complicated logic that you might have missed. Static analysis tools. Tools like Flake8, Pylint, MYPY, for Python, can identify code style issues, potential errors, and areas where code can be simplified. Code coverage analysis. Tools like coverage.py, for Python, can show you which lines of code are actually being executed by your tests. This can reveal dead code or sections of code that are never used. Profiling. Profiling tools help you understand how your code is performing. If you see bottlenecks, you can then focus on optimizing those specific areas, potentially eliminating unnecessary operations. Debugging. Step through your code with a debugger. This can help you understand the flow of execution and identify variables or operations that are not contributing to the desired result. Rubber duck debugging. Explain your code line by line to an inanimate object, like a rubber duck. The act of explaining can often help you identify flaws in your logic or unnecessary steps. Version control history. Look back at your commit history. Did you add a feature or a block of code that you later realized was not needed? Don't be afraid to revert or remove code that is no longer relevant. Linters and formatters. Enforce consistent code style and automatically fix many stylistic issues that can lead to unnecessary verbosity. 9. The importance of refactoring. Refactoring is the process of improving the internal structure of code without changing its external behavior. It's a crucial step in eliminating and the unnecessary. Refactoring involves removing duplication as discussed earlier, create functions or classes to encapsulate common logic. Simplifying logic break down complex expressions into smaller, more manageable steps. Improving readability rename variables and functions to be more descriptive. Applying design patterns use established patterns, example strategy, factory, when appropriate, but only when they actually simplify the code. Breaking down large functions extract smaller, more focused functions from larger ones. Removing dead code delete code that is no longer used. Refactoring example, Python. Explanation The refactored code separates the filtering and squaring operations into separate functions, filter_data and square_data, making the process_data_ refactored function more readable and easier to understand. List comprehensions also improve conciseness. 10. Code examples in Python, with comparisons. Let's provide a more extensive set of examples to illustrate the concepts discussed. Key takeaways. Readability is paramount. Write code that is easy to understand, even if it means adding a few extra lines. Simplicity over complexity. Favor simpler solutions over complex ones, unless the complexity is truly justified by the requirements. Don't be afraid to delete code. If code is no longer needed, remove it. Version control systems like Git make it easy to recover deleted code if necessary. Continuous improvement. Refactoring is an ongoing process. As you learn more about your problem domain and the best ways to solve it, you'll often find opportunities to simplify your code. Context matters. The optimal level of conciseness and abstraction depends on the specific context of your project. A small script might be more concise than a large enterprise application. By focusing on these principles and using the tools and techniques discussed, you can write code that is more efficient, maintainable, and easier to understand, eliminating and the unnecessary from your programming practice. Remember to prioritize clarity and purposefulness in your code. Good luck.